1 ohm. Okay, so this is the inductance value in ohm. Now what are the condition for the maximum power? So for the maximum power, ZL is equals to RTh minus J of XTh. So put the values. So it is ZL is equals to 1 minus J1. Now if you see the result, I have already told you in the last numericals that if you are having your load is in the form of R plus Jx, then it is RL load with lagging power factor, with lag power factor. If you remember the last question, then if your load is having like that R minus Jx, then it is RC load with leading power factor, if you remember. So if your impedance is RL circuit, then your load must be RC circuit. That is clear from the option. So we will just eliminate the option. First option, that is we will eliminate directly. That is wrong. And in the B option, a resistance in parallel with, it is also wrong. अगर resistance और resistance ही रहेगा, but inductor का capsule और capsule का क्या हो जाएगा? Inductor. That's the meaning of complex conjugate. If you are having plus in here, then minus is in here. So inductor becomes capsule and capsule becomes inductor. So due to this thing, this option is wrong. And one way to eliminate more option is, if the impedance is in series, then your load should be in series. So this parallel word is also removed. So we are having a resistance in series with 1F capacitor. So we have 1 ohm resistance. If you compare this R minus Jx, so yeah, R is 1 ohm and Xc is 1 ohm. If you solve this, Xc is what? 1 upon omega C. C is 1 upon what? Xc into omega. And how much is Xc? Xc is 1 and omega is 1. So it is 1 farad. So we are having the 1 ohm resistance in series with 1 farad capsule. That's why our option C is correct. So we are moving now next question. So हमारा next question देखते हैं क्या है. So we will see the next question with respect to the AC MPT. Let's see. Now, next question is, next question with respect to the maximum power theorem in AC is, a source VST, a source Vs of t equals to V cos 100 pi t has an internal impedance of 4 plus J3 ohm. Okay. If a purely resistive load connected to this source has to extract the maximum power out of the source of the source, its value in ohm should be. So our options are 3, then we have 4, and C option is 5, and last option is 7. So we will solve this question. Now what is the question? एक सोर्स है जिसकी वैल्यू इतनी है और उसका इंटरनल इंपीडेंस जो है 4 + j3, इसको ठीक से लिख लीजिएगा. इट इज जस्ट 4 + j3 ohm. 4 + j3 ohm. Okay, this is ohm. Now if a purely resistive load is connected to this source, has to extract the maximum power out of the source, its value in ohm should be. So first we will draw the diagram. What is the diagram with respect to this question? So we have a source whose value is like that, V cos 100 pi t. Now if we are having the general equation of the sinusoidal voltage, it is either in terms of cos or sine. ठीक है यहाँ तक. So we will have this. Similarly, we have a source impedance of this value 4 + j3, and you have to connect a load impedance, but the load impedance is completely resistive, that is RL, where JXL is 0. Agree? So you are having only the resistive load, and resistive load is variable also. So I can write like that, RL variable. So what should be the value of that R? Now if you see the result of the restricted condition part 3rd, so we have the RL equals to mod of ZTH, that is equals to RTH square plus XTH square. So we have RTH 4 ka square 16, XTH is 9 ka square, sorry 3 ka square 9, so it is 4 square plus 3 square. 4 square is 16 and 3 square is 9, and 16 plus 9 25, and root of 25 is 5. So we have to connect a load resistance of 5 ohm to have the maximum power at the load. So we will now next solving the next numerical. देखते हैं हमारा next numerical क्या होगा. So next numerical for the maximum power theorem in AC is, so let's start the next numerical. Start करते हैं हम अपनी next problem with respect to the maximum power theorem in AC. So first we will see the problem. The next problem is determine the load impedance. Determine the load. Just wait. Just change the marker. Oh, you determine the load impedance. Determine the load impedance ZL that maximizes the power drawn from the circuit, from the circuit. Okay, and what is the value of maximum power? What is the value of maximum power? ठीक है यहाँ तक. So let's draw the question. We have a source with tan angle 0 degree. Then we will have 4 ohm resistance. Then we will have 8 ohm in series with a capacitor whose value is minus J6 ohm. Then we have J65, J5 ohm, and lastly we have the load resistance, load impedance. Okay, so this is a question that we have to discuss. Let's see the question. Okay, now so the first step of the maximum power theorem in AC, removed your load resistance, removed load resistance. Okay, so if you remove the load resistance, then we will have the diagram like that. Okay, so it is tan angle 0 degree, and just wait, it is also, I will make some correction on this. So it is Vt equals to, actually it is given as tan cos omega t. Okay, it is given like that in the question exactly. So we will have, it is 4 ohm, then it is 8 ohm, then it is minus J6 ohm, and it is inductance of J6 ohm. Okay, so this is your load point where we have to calculate the VTH now. So if you see, there is a single source that will provide current in this direction, but up to here the current is same because both are in series. But at this point, this current is 0 because there is open path. So whole of the current will be diverted into this part. So this voltage is 0. Voltage across J6 ohm is 0 because there is no current. Okay, so this voltage across the 6 ohm is 0, then this voltage is across this impedance. So I will just apply the voltage division rule. So VTH equals to tan cos omega t multiplied by this is in series 8 minus J6 upon the total, that is 8 minus J6 plus the 4. Okay, so this is your VTH value. So we will have, it is tan cos omega t 8 minus J6, and then we have, it is 12 minus J4. So how much is it is coming? So let's see, it is, the value of voltage source is, on calculating this value you will have, the answer is 7.45 angle minus 10.3 degree volt. It is just degree volt. So this is your step number first. Maybe you have the calculation problem in AC, but as we solve the AC problems, you will have crystal clear the concept of AC. Okay, so here we have to just cross rationalize, then we will have to take the polar form. How we will take the polar form, we will see in the AC also. So the second step is what? Finding RTH, finding ZTH. So ZTH is what? So for finding ZTH, the voltage source should be shorted. So it is short. Then we have 4. It is 4 ohm. Then we have 8. And then capacitor whose value is minus J6. It is 8 minus J6, and we have an inductor of J6. Sorry, it is J5. J5. So here we have to calculate the ZTH now. If you see the ZTH, let this is Z1, let this is Z1, and this is Z2, and this is Z3. So if you take the series and parallel combination, Z1 and Z2 are in parallel, and that combination is in series with J5. So I will write the expression of ZTH. ZTH is what? Z1 into Z2 divided by Z1 plus Z2, and that combination is in series with Z3. So what is Z3? Let's write here. So we will have, how much is Z1? That is 4. And how much is Z2? It is 8 minus J6 upon 4 plus 8 minus j6 in series with how much? It is j5. Okay, so if you solve this value, it is coming out, it is 2.93. It is 2.93 plus j 4.467 ohm. So this is your ZTH now. So in AC, if you feel the some complexity, then you have to clear your concept when I teach you the AC. So let's start the next part of this. So we have calculated VTH, and where is VTH? Let's mark it here. So your VTH is what? 7.45 angle minus 10.3 volt. You can also write the voltage as VT equals to 7.45 cos omega t minus 10.3 degree. Okay, you can also write like that. Okay, and similarly we have ZTH is what? ZTH is 2.93 plus j 4.67 ohm. Agree? Now let's erase all the things. So just erase all these things. Now we will draw the Thevenin's theorem model. So because we have calculated VTH and ZTH, so it is your VTH, that is what? VTH is equals to 7.45 angle minus 10.3 degree. Similarly, we have ZTH is how much? This is your ZTH. Let's draw with another pen. So it is ZTH is how much? ZTH is 2.93 plus j 4.67, and this is your load. That is load here. So if you see your load, then load is variable, and according to the maximum power theorem. So according to MPT, maximum power theorem, what is the condition? ZL should be equals to ZTH complex conjugate. Now you have calculated the ZTH, so your ZL is equals to 2.93 real part as it is and minus of imaginary part. So this is your ZL. Okay, now what is your maximum power formula? So maximum power formula is P max is equals to VTH square upon 4 RL. So if you put this value, VTH is this and RL is this, so you will have answer. I will just put your answer because it takes lots of time. It is 2.36 watt. So this is your answer, because I take here the conventional problem to clear all the concept. So this is about the this question. Next we will take one more question on the maximum power theorem. Let's take the question. Now next question is, in the circuit shown in figure, in this circuit shown in figure, find the RL, find the RL that will absorb the maximum power, Okay, so we have to calculate. And what is the diagram? Diagram is, it is VT equals to 150 cos omega t plus 30 degree. And what is your R? R is 40 ohm. Then we will have a capacitor whose value is minus J30. Then inductor, and inductor is J20. And this is your load, that is RL. Okay, this is variable. So this is a problem. Now we will see how we will solve this problem. Okay, so let's see the problem. So here we have to only find, in the circuit shown in figure, find the value of RL that will absorb the maximum power. So our only task is what? RL is, if you remember, RL equals to RTH square plus XTH का whole square or mod of ZTH. So our main task is to find the ZTH. So how we will find the ZTH? For the ZTH, voltage source should be short, and just you remove the load resistance. So draw the diagram. Short, then it is 40 ohm, then it is capacitor of minus J30. Then we have an inductor of how much value? It is J20. And this is your what point? ZTH point. Okay, now let it is Z1. Let it is Z1 and it is Z2. But Z1 is what? If Z1 is equals to 40 minus J30, because these are in series. So what is your ZTH? If you see the ZTH, both are in parallel. So if you see ZTH equals to Z1 into Z2 upon Z1 plus Z2. So if you see the numerical value, 40 minus J30 into how much? J20 upon, what is that? Both are in parallel, so 40 minus J30 plus J20. If you solve something, 40, just multiply that. So it is 8, 4 2 is 8, 800, but J800, then J square is minus, that is plus, so it is 600, and divide by what? So it is 40 minus, sorry, plus minus J10. Okay. Now next, what? Next step is what? It is just 40 plus J10 and 40 plus J10. Okay. Then what is the next? If you multiply these two, then we will see later. 100, 600 plus J800 multiplied by 40 plus J10 and A square plus B square. So it is 1600 and it is 10, that is 16, that is root, it is 700. 14 square is 1600 and 10 square is 100. So it is A square plus B square. So A square plus B square, that is 1600 plus 100, that is 700. 700. Okay. Now if you multiply and solve with calculator problems, then you will have ZTH is 9.41, the real part 9.41, and then we will have 22.35. 22.35. This is your ZTH. Okay. Now if you want to calculate your RL, and RL is what? 9.41 ka whole square. Then what is that? 22.35 ka whole square. If you solve this, you will get your answer. Okay. So up to here we have calculated the various problem related with AC, and we will now stop AC theorem with respect to AC. The last case of the AC theorem was remaining, that we will discuss now. So I will just summarize AC case. So अगर मैं AC की बात करूं तो AC में हमने जनरल केस जो होता था उसमें क्या होता था? लोड इंपीडेंस वेरिएबल होता था, और उसकी अगर कंडीशन देखें तो ZL बराबर ZTH कॉम्प्लेक्स कॉन्जुगेट, और उस समय मैक्सिमम पावर होती थी VTH स्क्वायर अपन 4RL। एफिशिएंसी जो होती थी वो 50% होती थी, बट अगर हम रेस्ट्रिक्टेड कंडीशन में देखें तो रेस्ट्रिक्टेड कंडीशन में हमारा जो लोड है ZL इक्वल्स टू RL प्लस JXL, उसमें पहली रेस्ट्रिक्टेड कंडीशन की क्या थी, जो RL है वो वेरिएबल है बट XL कांस्टेंट है, तब जो हमारा फॉर्मूला था RL का क्या था, RL इक्वल्स टू रूट ऑफ RTH स्क्वायर प्लस XL प्लस XTH का होल स्क्वायर। फिर हमने दूसरी एक्सप्रेशन क्या देखी थी, हमारा जो लोड इंपीडेंस था ZL इक्वल्स टू RL प्लस JXL, उसमें हमने क्या देखा था, हमने कंडीशन डाली थी कि RL जो है फिक्स है, XL वेरिएबल है, तो हमारा उसका आंसर क्या आएगा, XL इक्वल्स टू माइनस XTH। Then the last condition was what? If your load is having only DC part and which is variable, so उस समय RL की जो वैल्यू होती थी that is root of RTH square plus XTH square और mod of ZTH। तो सारी टाइप की लगभग हमने प्रॉब्लम देख ली, कुछ कन्वेंशनल प्रॉब्लम भी देखी है। So you will very much comfortable in your AC maximum power theorem with AC। अब हमारा जो लास्ट केस रह गया है मैक्सिमम पावर थ्योरम इन with the transformer, how it was, let's see the maximum power theorem with transformer। So start करते हैं maximum power theorem with transformer। स्टार्ट करते हैं अपना लास्ट केस maximum power theorem का। So maximum power theorem का लास्ट जो केस था हमारा था वो था maximum power theorem with transformer। So we will see maximum power with transformer now I think you have basic knowledge of transformer, so I will assume that you all have the basic knowledge of transformer, otherwise your transformer lecture will cover all the details now। So अब हम चेक करते हैं हमारा जो आइडियल ट्रांसफार्मर है, we have an ideal transformer, okay, and we have the number of turns N1 upon N2, clear है। Now I take N2 upon N1, that is N, and that is also case। Now let confirm, now N2 upon N1 is called transformation ratio and N1 upon N2 is called turns ratio। So please अपने दिमाग में ये बात रखिएगा। So it is positive। Now I'm having here the input resistance of this transformer and we are having a source here, this is RS, and here I'm having a load resistance, I'm having here a load resistance। Now if you see the transformer or you study the transformer, the winding resistance of the transformer are fixed, because when the transformer is designed, their resistances or impedance or whatever you say, the whole word is impedance is constant, so it is constant, okay। Similarly this RL is constant, now I will take example how they are constant and how we relate your maximum power theorem with transformer। So let's see, this is your transformer and now here we are having on the left hand side we are having an amplifier, audio amplifier, okay, and on the load we are having an speaker, okay, this is speaker and this is your load amplifier, audio amplifier। Now to have the maximum sound from the audio amplifier to the speaker, now what is that, अगर हमें इस ऑडियो एम्पलीफायर से मैक्सिमम साउंड चाहिए, क्या चाहिए, मैक्सिमम साउंड चाहिए, तो क्या होना पड़ेगा, इसका जो इनपुट इंपीडेंस है और जो ये है इसका इंपीडेंस है, दोनों क्या होने चाहिए, फॉर मैक्सिमम पावर RS should be equals to RL। now how we can match, now RL is low value, अगर स्पीकर का आप लोग रेजिस्टेंस देखेंगे तो कैसा होता है, इस लो